All right, so today we're going to be looking at simplifying square roots. We have looked at using the Pythagorean theorem and the distance formula that often results in getting a square root answer, which we then can punch into our calculator and usually get a rounded decimal, unless it's a perfect square, of course. But there are methods for simplifying a square root so that the number underneath the square root gets as small as possible, which also allows numbers to get out from underneath the square root that can be canceled out. So basically it's going to be a way of keeping an answer exact, but also sort of like reducing a fraction. We're going to simplify the square root a little bit. So in order to do that, we are going to need to think about perfect squares. And so when we're talking about a perfect square, we're talking about a number whose square root is a whole number. All right, so for instance, 1 is a perfect square because the square root of 1 is 1. 4 is a perfect square because the square root of 4 is 2, is a whole number. 9 is a perfect square because the square root of 9 is 3, which is a whole number. And you can think of the next one essentially go in reverse. So 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225, and that would be our first 15 perfect squares. These are great numbers to memorize, so that when you are doing some mathematical calculations in the future, oftentimes squares or square roots are used, and it's nice to know your perfect squares. You can go even higher than 15 squared. I'm sure as you are doing your math, you can maybe commit some of these to memory. Okay, so when we are doing our simplifying of a square root, we're going to be using those perfect squares, and we're going to also use something called the product property. And the product property says something like this. The square root of a product equals the product of the square roots of the factors. Okay, you might need to read that a couple times to let that sink in, or maybe an example will help it sink in a little bit more. So the square root of a product, in other words, the square root of two things being multiplied, equals the product of the square roots of those factors, okay? So probably still doesn't quite make sense, does it? So let's take a look at an example, all right? So the square root of a product, so the square root of two things being multiplied together, so the square root of 9 times 5, for instance, equals the product of the square roots of those factors. So what that means is it's the square root of each one of those factors. Remember, a factor is two numbers being multiplied together to equal something else. So the product of those factors, the product of the square roots of those factors, I should say. So the square root of 9 times 5 is equal to the square root of 9 times the square root of 5. So we can sort of separate those out into two separate square roots that are being multiplied. And then since the first of those factors, and this is ultimately what we're going to want here, is a perfect square, 9, that means that we can then take the square root of that and get a whole number. The square root of 9 is 3. So this ends up being 3 times the square root of 5, which is normally just written like 3 root 5. We don't usually write the multiplication sign in there. So 3 times the square root of 5 is going to be the same thing as this original statement up here, the square root of 9 times 5. All right, now where we normally see that, by the way, it's what we did there is we got a number out from underneath the square root, this 3, and then the number underneath the square root becomes smaller. So what we're going to do here is see if we can use that idea to simplify each square root expression here. So the main thing that you're looking for is under the square root, you're looking for any factors that are perfect squares, aside from 1, because 1 is a factor of everything and it won't really simplify with just knowing 1 is a perfect square factor. But we can think about the factors of 24. Like you said, 1 is a factor. 1 times 24 would be factors of 24. 2 times 12 is, of course, 24 has lots of factors. 3 times 8 is, 4 times 6 is. And so we're thinking about the factors, but the one that we want is the one that has a perfect square in it. The only one of these numbers that's a perfect square is 4, right? 4 is a perfect square because the square root of 4 is 2. Okay, so therefore the square root of 24 we can think of as the square root of 4, and actually I'm going to do this, the square root of 4 times 6. All right, because 4 times 6 is 24, so I'm just breaking that into 2 separate numbers. And what we learned from the product property above here is that that becomes the square root of 4 times the square root of 6. All right, and then the square root of 4 is 2. So this becomes 2 times the square root of 6. That is called the simplified root. That is the, back up here, simplifying a square root. So that's called simplifying a square root, or simplifying a radical, or something like that. So we have 2 times the square root of 6, which is the same thing as the square root of 24. Now that might not seem simpler because we actually have 2 numbers instead of 1 number there, but essentially what we want to do is we want to get the number underneath the square root as small as possible, and also get something out from underneath the square root. Because if we're going to then use this further in the problem, maybe the 2 cancels out, or maybe the 2 gets multiplied by something. So it gives us a little bit of option there, and also keeps our number exact. Right, so we don't have a rounded decimal here. That's still the exact same thing as the square root of 24. And if you don't believe me, punch into your calculator the square root of 24, and then also punch into your calculator 2 times the square root of 6, and you'll see that they are the same. Okay, so I'm going to go through some of these others, maybe just a little bit faster than that. But with 32, again, factors of 32 might be something like 1 times 32, 2 times 16, and let's see, 3 doesn't, but 4 times 8. I think that's it, right? And we're looking for any of these that are perfect squares. Now, in this particular case, we actually have a couple perfect squares. 16 is a perfect square, and so is 4. Again, we don't really think of 1 because that square root of 1 is still just going to be 1, so it doesn't really simplify. When this is the case, what we want is the bigger perfect square to use. All right? So in this case, what we're going to do is break up 32 into, I'm going to go back to green here, the square root of 16 times 2. And I normally put the perfect square first. So that becomes the square root of 16 times the square root of 2. And that becomes the square root of 16, which is 4 times the square root of 2. So this would be the simplified square root form. 4 times the square root of 2 is the same thing as the square root of 32. What if you're like, oh, 4 is a perfect square, I'm going to use 4. So here's what would have happened if you used 4. So I'll actually do this problem over here to the right here again, but I'm going to use 4 and 8. So the square root of 32 is the same thing as the square root of 4 times 8. And that's fine, which is the same thing as the square root of 4 times the square root of 8, which is the same thing as 2 times the square root of 8. So you get to this point and be like, oh, I'm done. That's a simplified square root form. Actually, it's not, because 8 still has a perfect square factor, 4. still goes into 8. So you would have to keep going with that. Now notice back up here, when we stopped at 6, because although 6 has factors like 3 and 2, neither one of these is a perfect square. So that's as far as we can simplify it. However, with 8, one of the factors is still a perfect square. So we can still keep going with this and say, okay, well that's 2 times the square root of 4 times 2, which is the same thing as 2 times the square root of 4 times the square root of 2, which is the same thing as 2 times the square root of 2, because the square root of 4 is 2. And 2 times 2 is 4, so 4 square root of 2. Notice we end up with the same answer as we ended up here, but it took us a lot more steps. So, moral of the story, try to figure out first what the biggest perfect square factor is of your number, and use that. Now, if you can't figure that out, start with the small one and then go through the steps like I did here. That's still fine. You'll still get to the same answer. But if you can figure out what the biggest perfect square factor is, then that is better. It's faster. Okay? So the square root of 125. All right, any perfect square factors? Yeah, and I'm not going to start listing out all the factors. I'm just going to start thinking, okay, what is a perfect square factor of 125? Okay, 25 is, right? So 25 times 5. So this becomes the square root of 25 times 5, which is the same thing as the square root of 25 times the square root of 5. Square root of 25 is 5. So 5 times the square root of 5 is our answer. That's the same thing as the square root of 125. And 5 does not have any perfect square factors. In fact, 5 is a prime number. So that is it. Okay, what if you have something like number 4? Well, in this case, what we have here is kind of a little bit of the reverse of what we had above, right? You have 2 separate square roots. So what we do with that is we multiply them together using kind of the reverse of the product property. So this becomes the square root of 10 times 2, which is the same thing as the square root of 20. All right. And now let's look at that. Are there any perfect square factors that go into 20? And hopefully you're saying, yes, there is. 4 times 5 is 20. So we can break this up into, now, the square root of 4 times 5, which is the same thing as the square root of 4 times the square root of 5. And the square root of 4 is 2. So 2 times square root 5 is the simplified root form of that. All right, what if we have something like number 5? We kind of alluded to what's going to happen to number 5 back over here in number 3 with the square root of 32 problem. But you have that number out in front of the square root, and that's fine. So that number is going to stick around, so we'll still have that 5. But then we're going to think about, okay, what are any perfect square factors of 18? And hopefully you're saying yes, 9 is a perfect square factor of 18. 9 times 2 would be 18. And so this becomes 5 times the square root of 9 times the square root of 2, which is the same thing as 5 times 3 times the square root of 2, because the square root of 9 is 3. And 5 times 3 is 15. So the simplified version of this right here is 15 times the square root of 2. All right. The back page here is just some workspace. I may or may not have a Desmos activity for you to work through next or later on in the lesson today. So if you do that, here's some workspace as you're working through the Desmos. Now, if we don't do that, then you don't need to utilize the space for the Desmos, but if there's any other work that you have related to simplifying roots and you want to use a little scratch paper, feel free to use it